Welcome to Understand the Math. In this video, we're going to talk about concavity and inflection points, and then walk through some example problems. Let's begin by learning about concavity. Concavity describes how a graph bends, whether it curves upward or downward. If a curve is concave up, it curves upward like a smile. And if a curve is concave down, it curves down like a frown. Another way to visualize concavity is with secant lines. If you draw a secant line between any 2 points on a curve that is concave up, the secant line will be above the curve. If the curve is concave down and you draw a secant line between 2 points on the curve, the secant line lies below the curve. Concavity is also related to the rate of change of a function. When a curve is concave up, the rate of change of the function, or the slope of a tangent line to the curve, is increasing. When a curve is concave down, the rate of change of the function, or the slope of a tangent line to the curve, is decreasing. Just to recap, when a curve is concave up, the rate of change of the function is increasing, and when a curve is concave down, the rate of change of the function is decreasing. Let's now walk through some example problems of identifying concavity. In each example, we're going to determine the intervals on which the function is concave up and concave down. In this first example, we can see that the curve is concave down. I'll highlight that part. And then it switches to be concave up. The point where it switches from concave down to concave up is at this point, and that occurs at the point x is equal to 2. The function is going to be concave up on the interval from 2 to infinity, and then it's going to be concave down on the interval from minus infinity to 2. Let's now look at our second example. You might want to pause the video and see if you can complete this example on your own. The graph of this function is concave up, and then it switches to concave down, and then it switches back to concave up. The first change occurs at x is equal to 0, and then the second change occurs at this point, and if we trace up, we can see that that point is x is equal to 3. Now let's list the intervals where our curve is concave up and concave down. Our curve is concave up in 2 intervals. The first interval is from minus infinity to 0, and then we'll put an and here, and write down the second interval, which is from 3 to infinity. Now let's look at where the curve is concave down. The curve is going to be concave down in the interval from 0 to 3. Let's now talk about inflection points. An inflection point is a point on a graph where the concavity changes. It's the point where the curve switches from concave up to concave down, or where the curve switches from concave down to concave up. We're now going to walk through some example problems where we're going to find all points of inflection on a graph. In our first example, our curve changes from concave down to concave up. This change occurs at this point, which corresponds to x is equal to 2 and y is equal to 3. Our inflection point is then the point 2, 3. Let's now look at our second example. You might want to pause the video and see if you can complete this example on your own. In this example, our concavity changes at 2 points. it changes from concave up to concave down, and then it switches back to concave up. The first change occurs at the point 0, 0, and then the second change occurs at this point, and at this point, x is equal to 3, and y is equal to minus 2.25. Let's now write down our inflection points. Our first inflection point is 0, 0. And then our second inflection point is the point 3 minus 2.25. Let's do a quick recap. Concavity tells us how a graph curves up like a smile or down like a frown. And inflection points are just where the concavity changes. I hope this video helped you understand these concepts better. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.